Hi, I'm Chuan Jiang. My background is in condition monitoring and data analytics, and I'm a developer on the application software team at National Instruments. In this video, I'm going to show you how we can use the AI DSA software front panel to acquire vibration signals. This slide shows the instruction and required dependencies to install it. If you already have it installed, you can find it by pressing the Windows key, typing in dynamic, then choosing it from the search. The NIDSC software front panel provides a graphical interface for configuring DACMAX analog input hardware and performing interactive cursor-based inspection of time and spectral data. It has status LEDs return the verification status of DACMAX analog input task, acquisition, and software trigger. Application control buttons are in the ribbon at the top of the main application UI. System and device information are displayed in the top right table. The top graph displays the time domain waveform, the bottom one displays the discrete Fourier transform. The hardware I used in this video is a DSA demo box that has a fan for creating vibration. I connected the X-axis acceleration channel to the AI0 of AI9234 module and tachymeter channel to AI1. The module is in slot 1 of a CDAC9174, which is connected to the PC. On the first launch of the DSC SFP, the application initialized the DACMAX configuration and the application settings. The application identifies the first DSA device and adds all input channels to the channel table. On future launches, the application reloads the last configuration. Here I have my first input channel, CDAC mode 1 AI0 for vibration data acquisition. Acceleration as a measurement type, the sensitivity is 175 mV per G. The second input channel, CDAC mode 1 AI1, is for tachymeter signal. Change the coupling to DC. This is a voltage measurement, so sensitivity is just 1000 mV per volt. We can also go to the application settings to choose the directory where to save the data, login duration, window type, and averaging mode, etc. Everything looks good, and let's run it. As I increase the fan speed, we can see that the data in time domain and the frequency domain are updating. I can zoom in on either graph. Here you can see the frequency domain of most interest while we change the fan speed. When we are acquiring data, we can use the record function to record the data up to 60 seconds as a TDMS. We can also save the single screen worth of data into a TDMS file. If we want to load the data we previously saved, we can click the load and select the one file to display. These datasets also contain the hardware configuration used to tick them, so the same exact measurement could now be run again. Okay, in this video, we have used the free interactive DSA software front panel available to the NI community to acquire dynamic signal from the DSA analog input channels, evaluate acquired signal in both time and frequency domain, reconfigure and verify DACMAX hardware configuration, verify time waveforms and frequency spectra, save acquired data and DACMAX configuration to file. Check out other videos on AI.com to learn more about the sound and vibration measurement suite.